Guys, I want us to help each other on a few things here. Let's just look at the given diagram here where we are having this 30 kg that is placed on an inclined plane. Then now, they said a force, an applied force, it's applied on the 30 kg and then it starts to move up the inclined plane from, of course, we can say between point A, C. So then now, let's just say, assume they say to you, throw a labeled free body diagram of all the forces acting on this 30 kg. There's something that I want to explain. So then now, in drawing a free body diagram, mind you, we indicate the object of interest using a what? Using a dot when we are drawing a what? A free body diagram. So the first force experienced by this 30 kg, we are having what we call what? We are having what we call gravitational force, right? And then now, secondly, this one will experience what we call normal force. Mind you, normal force, we are saying it's perpendicular to the surface. It doesn't mean that it's always acting or pointing upwards. No, it's just perpendicular to the surface. So it can point to any direction as long as it is perpendicular to the what? To the surface. Then secondly, we've got this force which we call it the what? The applied force, which is acting up the inclined plane. And then again, we are having what we call the kinetic frictional force, because if it's moving, once it starts moving automatically, not unless we are told it is moving on a smooth surface or the surface is frictionless. So there's a kinetic frictional force which is acting down the inclined plane. Right. Then now, I want to assist you guys in terms of identifying as to whether a certain force is doing positive work or negative work on an object. Again, you must be able to use the correct angle for that particular force. Right, let's go. These are the forces experienced by this object. So then now, allow me to extend to include, to remove the gravitational force and being replaced. The gravitational force, I'm going to replace the gravitational force by the two component, which is the first component that is perpendicular to the surface, which is our what? Our FG what? FG perpendicular. And then now, when you know that FG perpendicular is equal to mg what? Mg cos of the what? Cos of the angle. Then again, I'm going to again include the next component. The next component in this case is one FG what? FG parallel. So when you know as a learner that FG parallel is equals to mg what? Sine of the what? Sine of the angle. So these are the forces that are experienced by the object as it moves up the inclined plane. So then now, let's start by paying attention to the normal force as well as what? FG perpendicular. So then now, the normal force, mind you, we are saying the work done by the normal force, it's gonna be what? Normal force multiplied by the what? The displacement, and then cos of the what? Cos of the angle. So then now, let us look at theta. Now, theta is the angle between the vector of the normal force as well as the vector of the what? Of the displacement. So the vector of the displacement, there is the vector of the displacement acting up the incline. Then there is the vector of the what? Of the normal force. So the angle between the normal force and the vector of the displacement, there it's what? It's 90 degrees. Meaning your theta there, everything here, your normal force multiplied by the displacement, then it's going to be what? Cos of 90 degrees. And that's in, as we are doing mathematics, we know that cos of 90 degrees, it's equals to what? It's equals to 0. So everything multiplied by 0, it means that the work done by the normal force, it's going to be what? 0 joules. You pay attention to that. And then again, we come to this one, work done by FG perpendicular. As we consider the work done by FG perpendicular, we can say our mg cos theta multiplied by the displacement, then cos of the what? Cos of the angle. Mind you, this theta, it is the angle between the what? The angle of the incline between this part and that part. The angle, this theta is the angle of the incline, and then this theta is the angle between. There we go. There is the vector of our displacement and the vector of the what? The vector of the FG perpendicular. So the angle in between, we can all see that it is forming what? 90 degrees. Meaning again, we'll be having what? Cos 90 degrees, which will result into what? Into 0. Meaning, what is it that you've got to bear in mind as you approaching for your final examination is that all forces that are perpendicular to the surface, they do a work of 0 joules on a given object, because the angle between the vector of those forces and the displacement, it's 90. Therefore, cos 90 will give us 0. Anything multiplied by 0, then it will result into a work of what? 0 joules. I'm done with forces that are perpendicular to the surface. Now, let's proceed. Let us consider those forces that are what? Are parallel to the surface. We are having 3 forces that are parallel to the surface. We're having the applied force acting up the incline, Fk acting down the incline, Fg parallel acting where? Down the incline plane. So then when considering the applied force, right, and the vector of the displacement, it is like this. The applied force and the vector of the displacement, they are pointing towards the same direction. As a result, the applied force, it is doing a positive work on the 30 kg. Therefore, if this is the case, always your theta, it's going to be what? 0 degrees. Now, let's look at our Fk. The vector of our Fk is towards that direction. There, it's our Fk. The vector of your displacement is towards this direction. So we can see that the kinetic frictional force, the vector of the kinetic frictional force, as well as the vector of the displacement, they are pointing in opposite direction. Then now, it means the kinetic frictional force is doing what? Negative work on the 30 kg. As a result, your theta here, it's going to be what? 180 degrees. Of course, this one will give us cos 108, it's going to be what? -1. Cos 0, it's going to be what? +1. We go to Fg parallel. Your Fg parallel, it's acting down the incline plane. The vector of your displacement, it's acting up the incline plane. So we can see that both of the Fg parallel and the vector of the displacement, they are pointing in opposite direction. As a result, your Fg parallel, in this case, in this instance, it is doing a negative work. Therefore, your theta in this case is going to be what? 180 degrees. So then now it means for forces that are parallel to the surface, your theta can either be 0 or 180. 0 if that object is doing positive work. How do you know? The vector of the force and the displacement in the same direction. Positive work. 180 if that force is doing negative work. How do you know? The vector of the displacement and that force, it's pointing on opposite direction. As a result, your angle there will be what? 180.